So let us look into a brief introduction about algorithms. Algorithms are step-by-step procedures to solve a problem. So the simple definition of an algorithm is, and that is, algorithms are step-by-step procedure, step-by-step process to solve a problem, to perform a task. This is the simplest definition of an algorithm. Step by step process to solve a problem. And whenever we have an algorithm, we should try to optimize its performance as in terms of time and space. So we have various common algorithms, like we have various sorting algorithms, searching algorithms, graph traversal algorithms. These are the various common algorithms that are there and which we are going to see eventually. Now, the choice of the algorithm, whatever algorithm that we are going to choose, will depend upon two things. It will depend upon what are we trying to solve, and the second is what data structure have we used. Consider, let's say if I want to make use of a stack, then in graph traversal algorithms we have DFS and BFS. DFS uses stack. So if consider if I cannot use a queue, then in that case I cannot apply breadth first search there. So like this we have various data structures, and what algorithm we'll choose will depend upon the data structure. So we should analyze the time complexity and space complexity of algorithms. There are various characteristics of an algorithm. An algorithm will always have well-defined input and well-defined output. An algorithm will have well-defined input and well-defined output. The steps will be clear and unambiguous. The general English meaning of ambiguous is confused. But here in an algorithm we will have clear and unambiguous steps. The number of steps here are going to be finite. Finite as in the number of steps are going to be countable. I cannot have incountable number of steps in an algorithm. Algorithm is language independent. It's programming language independent. That is, it can be once I have the algorithm, I can change it to Java, C, C++, or Python, whatever language I want to convert it. And it is feasible. Feasible as in it is a possible solution to do. There are various types of algorithms. Sorting algorithms can be bubble sort, merge sort, quick sort. Then there are various searching algorithms. Searching algorithms can be linear search, binary search. Then we have graph algorithms, Dijkstra's algorithm, A star search algorithms. Then we have dynamic programming algorithms like Fibonacci sequence calculation, knapsack problem. So these are the various dynamic programming algorithms. Then we have greedy algorithms, Huffman coding, Kruskal's algorithm. All these come under greedy algorithms. These we are going to see in our forthcoming units also. So algorithm optimization. Optimization means making efficient use of whatever resources we have. This can be done in two ways. One is time complexity and another one is space complexity. Now the time complexity is measured in terms of big O notation. This we are going to see in the following topic also. Big O notation. That is, how much of the space gets utilized, that can be measured in the terms of big O. Then there is space complexity. Space complexity measures the memory usage of an algorithm. So when we understand these complexities, time complexity, space complexity, we can develop applications that can perform well. Then let's say if I have complexity, if I have to talk about big O notation, if I have adding two numbers, so now adding two numbers, the statement finally is C is equal to A plus B, and it's going to take only one step to execute. How many, whatever inputs the user might give, still I'm going to get two numbers, and the program will be to add two numbers, and it's going to take me only O of one step. But consider a loop. Here in the loop, the user might give, let's say 20, or the user might give 20,000. Now the loop can be any number, and so the running is going to depend upon this n, whatever the user specifies. So that's why here the complexity will be O of n. If I have a nested loop, then there is an outer loop. For every iteration of the outer loop, the inner loop is going to run n times. So it's going to be n cross n. For every iteration of the outer loop, the inner loop is going to run. Consider if both outer and the inner loop are designed to run for n and n times, then in that case I will have n cross n, or I can say n square as the complexity for the nested loop. Consider binary search. In binary search, my search area gets divided by half every time. So if it is 16, it becomes 8. If it is 8, it becomes 4. If it is 4, it becomes 2. If it is 2, it becomes 1. It gets divided into half every time. So such a situation is log n. So there the complexity is O of log n. Let's say if I have 64. 64 is nothing but 2 to the power. 2 to the power 4 will be 16, 5 is 32, 6 is 64. So now if you see 64 to 32, step number 1, 32 to 16, step number 2, 16 to 8, step number 3, 8 to 4, step number 4, 4 to 2, step number 5, 2 to 1, step number 6. So 2 to the power 6 is 64. Log of 64 to the base 2 will be 6. So it is going to take me 6 steps. That is what it tells over here. Log of 64, 6. So this is going to take me 6 steps to reach to the solution. So this is the basic introduction to algorithms.